All right. Can you guys try, some of you? What do you think are the differences between single instance and R.A.C?
God, excuse me, can you repeat the questions, please? I'm not hearing very well.
I'm just asking, right, the difference between single instance and a R.A.C database. Single instance and R.A.C database. What do you think are some differences based on what we learned?
I think in single instance you got one instance and one database, and the R.A.C you got multiple instances to connect to the one database, just one storage.
Okay, good. Yeah. Okay. What else? Any other difference? You guys know? Any other difference you guys know between single instance and R.A.C?
Another difference is that in the single instance, in case of maintenance, if the instance go down, no user will be able to perform a DML. But in the R.A.C environment, it's a multiple instance. In case one of the instances will go down, the other instance will still work.
Okay. And how do we name it? How do we call it? The fact that if with R.A.C we have multiple instances and some other instances can support, connections in case one of them goes down. How do we call that? What does it mean?
Availability.
You mean what? Someone said something?
Yes, I said, is it availability?
So yeah, R.A.C ensure high availability because in case now of maintenance or crash, yes, the other instance can support, application connection if one of them goes down, right? But with a single instance, you have only one instance. So if that instance goes down, definitely, application team will have an outage. All right. So yes, that's correct. What other difference you guys know?
R.A.C ensure also the scalability. That means depending on the quantity of the load, or how many users have access in the database, the load capacity. We can increase the number of servers so that those users can easily have access to the database.
Yeah, that's correct. Scalability, and I explained some benefit of that when it comes to scaling up or scaling down, and that is what will be applicable. These holidays. You guys know that there are some companies that have more sales during holidays, especially the Black Friday that's coming. You guys see company like Best Buy or any other company that will be selling our stuff, at a lower price. Those companies will have more. What can I say? More their sales, right? Will increase, maybe double or triple, right? So and with that means that application used by either cashier or maybe application used online, the one that are using the web application they're using to, customer will be using to buy stuff. Those applications will be overloaded, right? The load will increase because the number of connections will increase, the number of sessions will increase, the number of transactions will also increase. And because of that, they have to prepare their environment, okay? And R.A.C is one of the best options as well for that because for them, if they know that they will have a temporal event like that, right? An event, it's a one-day event, okay? So they can start preparing their servers or their application to receive the load. And an example could be for them to be adding load for now, right? because the scalability is done online, you don't need any downtime, so they can just add more cluster. By adding more cluster, we definitely help them to save, to increase, the amount of resources available, and if we make the application run faster, users can easily, buy their stuff online. They will not encounter slownesses simply because we have more instances or more server to service connections. Okay, so that is the benefit of scalability. When you see that you have more sales, you can increase. When you see that you have, after the Black Friday, right, or maybe the end of this year, because we still have the Christmas and all those stuff. When we get to a certain period of time, some company, the sales, reduces, right? So those companies will definitely have to, those who increase, their instances just because of, the holidays, we may reduce their servers, right? And so it means that they are scaling up while they have more sales, and they are scaling down when the amount of sales decreases. Okay, so that is just how it works with scalability. What other benefit? What are the any other difference? You guys know single instance and rack.
I'll say the cost. So rack is a little more expensive. I don't know if it's a little, but it's more expensive than just the regular, because you have like the hardware, infrastructure costs, licensing, and management costs. Whereas the single instance, I don't think you need all that.
That's correct. Rack, we need to add more servers, and it means when you add more servers, that means you have to install another operating system on that. You have to install another database, another, the maintenance. Okay, you have to maintain those hardware. So definitely the cost will increase, not just the license, but also maintenance, also the cost of buying another hardware, right? So definitely that's correct. Yeah, more expensive, and it needs more skills, right? So a regular GBA who is comfortable with the single instances needs more skill in order to be able to manage a rack database. Okay, so there are multiple other components involved, not just the hardware, but you have to get comfortable with some terminologies, clusterware, and so on. Some of them will be talking about them, but yes, the cost is higher than the single instance. Also, the cost of ownership. Cost of ownership. Yeah. You guys ever heard of it? Cost of ownership. I think it's cost of ownership, yeah. You guys ever heard of it before?
Nope.
It means that, sometimes those people who are managing, can be more expensive, right? Than if you are in single instance. For instance, someone who is expert in RAC in the market, right? The job market can be more expensive than someone who knows only single instance. Does it make sense? So that's why sometimes in interviews, those people who have more experience in certain stuff can ask whether okay, more money than those who are not really that skilled in certain things. Especially when you are really good in rack, definitely you have more consideration than someone who is really good in single instance only. Just a comparison between those two. I'm not talking about any other project, right? So because if you are comfortable with rack, that means you can manage single instance. That is the base. So someone who knows rack definitely will know how to manage single instance. Okay, so the cost of ownership can definitely be higher than when you were managing single instances. Okay, any other difference you guys can think of now?
Yeah, I have one. I think. Okay, so with regard, we know that excuse me, with single instance. So each single instance, let me say each single instance is associated to one database, but with R.A.C, we have it's also very similar, but in terms of buffer cache, R.A.C generally manage each of their buffer cache to reduce, to optimize performance and to reduce input and output, unlike single instance.
Yeah, okay. So you are trying to talk about the global buffer cache. Okay. So yeah, yes, we have. We are not there yet because it's part of cache fusion. I'll be talking about it, global resource directory. Because now in R.A.C we have a shared buffer cache. So each instance has its own buffer cache, but there's a shared buffer cache. It's also what comes with the clusterware. Okay, and I will throw more light on it when I'll be talking about the cache fusion. Okay, or the global how the concurrency works as well. So yes, that's correct. A shared buffer cache. Yeah, but that one is a bit more technical, right? What you said, because you have to understand first of all what is buffer cache before you even understand what is shared buffer cache, right? So yeah, I'm just trying to get some differences, for someone who is not that comfortable with technical, with single instance or R.A.C, how you can just easily explain the difference between both, right? That is what yes. What you're saying is not wrong, right? But definitely, I want something, a bit easier to understand. What other difference do you guys know? Any other difference?
Yeah, so in R.A.C, we talk about nodes, while in single instance, we don't use that term.
Correct, that's true. We talk about node in R.A.C, that's true, yeah.
So, okay, so in terms of the file system, in terms of where and their data files are being stored. So each single instance have their individual data files and control files. Unlike R.A.C, that would probably have like you probably have the different nodes. They will have probably we have the general of data file, but each of the nodes will probably have their own undo table spaces.
Okay.
So they have shared data file in R.A.C environment.
Okay, yes. Okay, that's true. Yeah. The shared files, yeah, that's true. They have a shared storage in R.A.C, whereby on a single instance, each instance has its own storage. That's true. That's correct. Yeah, very correct. Do you know anything else?
So I think R.A.C is scary. Like
what do you mean by scary?
In terms of the network, in terms of the network, how to connect, it's really scary.
Oh, okay. If we talk about network, I know, yeah, that is general, right? So definitely is what I said, that you need more skills because there are multiple other things involved. So it's not scary though. So network, you're not the one to work on the network part, right? So why are you saying it's scary? So
Guys, I take a question, just a little question. And in the R.A.C, we got maybe 2 instances, more than 2 instances. And the customer is connected by a route. If you one node, you not start, for example, the one node is save up node E, the other one node B, but the node E is the node E, the database is not up, but the node B, the database, the node B is down. You can connect the database node B to node E.
okay. So you say the database is running on one node.
Yeah.
And that node is what?
The instance to node E is not E and not B, but instance is not E is down.
Okay.
But the node E, it got problem like for the server problem. You can connect the database node B to node E.
Connect the database from node B to node E.
You connect the instance. I say node E. We got two instances, node E and node B.
Okay, instance. The instance, we have one instance running on node E, another instance running on node
B.
Node B. Okay, node A and node B. So we have two nodes, node A, node B. One instance running on node A, the second instance running on node B.
Yes.
Okay.
But you can connect the instance one on node B to node E.
Okay, they cannot talk to each other.
Like the instance not the instance node B, the node E is down, but the node is good. But for node B, the node is it got problem, but instance is good. You can connect to the instance B to the node E.
Okay, what type of problem do you mean? The node is down?
The node is down, node B is down, but we wanna connect to node instance was the node B, but the node is down.
I think he's talking about like the database is down, but the instance is good.
If the database is down, or the instance will also go down.
No, I talk about the instance is good, but the server, if we talk about the server is down.
Okay.
The server is not good.
Okay, so I think I understand it. So let's rephrase it, okay, if it makes sense. So it means that you have two nodes, node A, node B, and okay, maybe it was one of you guys. That's why I was echoing, right? I felt like it was on my end. So what I'm saying is that, can you guys hear me?
Yes, sir.
Okay. So what I'm just trying to refer it to understand it better, right?
Yes,
so
sir.
You are saying that you have two nodes, node A, node B, and on node A you have an instance running, on node B you have an instance running, but node B is bad. The server is bad itself, right?
Yes.
And you are asking whether the instance that was running on node B can connect to node A.
Node A, but the instance the node A, you wanna this instance go down, you wanna just connect to the instance node B and node A.
Which server is down?
The
node
server,
node
server,
A or node B?
The server B is down.
B is down.
But you got two instances is running. But you want just you prefer connect the instance was not server B, it was down. You can connect the instance was not server B to server E. That's my question.
But definitely whenever a server goes down, everything on that server also go down. It's not like a server will go down and the resources will stay up and running. Does it make sense? So what do I mean by that? You have a computer in front of you, right? Take your computer as a server, okay? And on your computer, you install an application. You guys have multiple applications on your laptop, right? You guys have maybe Windows or the Windows package. You guys have you guys have maybe Zoom you install. You guys have maybe Notepad, all those applications you guys install maybe, right? Let's assume I take Zoom, an application you install. So if I shut down the computer, will Zoom be available?
No, it's not available. That's all my question, because we connected the cluster and the root directory. If like the cluster to server B is down,
everything goes down. Everything. Even the instance goes down. Everything.
Everything go down. The instance go down. That instance, that's my question. The principal was for the customer. that instance, you can just take the instance, go running like no different server.
No, that instance, right? It will go down, but what happened is what? Is that if on that instance there was an application service running on it, okay? That means people were connecting to the instance too, right? Through
Yes.
a service, database
Yes.
service, okay? In
Yes.
case that instance is going down, that is only if you enable it, because it's not done by default. So you have to create a service and make sure that you enable transparent application failover, so that if that node or that instance goes down, automatically the service will move from that instance to the surviving instance, okay, or to the failover instance. So you have to configure it, and we are going to configure transfer application failover, okay. So if you configure it, all the transactions that were taking place there will be redirected to the surviving instance. But the instance itself is not moving. The instance will stay down, right? But what you are saving is that you are saving the transaction, right? The sessions that are connected to that instance, because they are connecting to the instance through a database service. That service can move from that instance to the surviving instance, but the instance will stay down. I don't know if I'm answering your question.
Yeah, but my question was because if the customers go down, everything's go down. But
now, if the server, not the cluster where.
Okay, I said maybe if the cluster will go down.
If the cluster goes down, the server stay up, and the
But
instance will also go down. Yes.
The instance will go down.
Yeah.
My question is, you can, for the meantime, you can say like, I go take this instance, like I go take this instance, I go start off no different server. That's could be happen.
Okay. So that means it's like you want to relocate the instance.
Exactly.
To another server.
Yeah.
No, it doesn't work that way, right? Because when you are creating a database, a R.A.C database, okay, you specify on which server each instance has to run. So if it's a R.A.C 2 node, right, that means the instance, the R.A.C will come with two instances. Instance 1 will run on server 1, and instance 2 will run on server 2. So that instance you cannot relocate it, but you can relocate only the service or the listener or other services, but the instance itself will stay there.
Okay.
Okay. Yeah. So in case maybe you want to add more nodes, you add more nodes, and you want maybe, let's assume that node is bad, that server is bad. So you add another server, right? You add another server. There are some commands you will run, and automatically the database instance will also be created on that server. Does it make sense? So you can also add another instance to the new server. But the existing instance that was on that server, you cannot relocate it. It will stay like that. It will stay down with that server.
Okay.
Does it make sense?
Yes, I got it.
All right. Thanks.
Thank you.
No problem. Why are all the video down? A lot of people are out offline. Okay.
Mr. Gata.
Yes, Mr. Cody. Yeah.
In R.A.C environment, I want to find out if tables are also locked on exclusive mode.
What do you mean by table lock on exclusive mode?
Like a situation where a user will log into the database and like for example, two users want to update the same table at the same time.
Okay.
Right. So automatically there'll be one of the other user will be kept in a queue, and the table will be kept will be locked on exclusive mode. I don't know if it's also possible in this in R.A.C environment.
Of course, you can lock a table. Okay, you can lock a table. So that is basically, it can happen. Also, you can do it for the block as well. Okay. So what you are saying is that you will have in R.A.C you will have the block can have multiple status. Okay. And we will talk about those stuff. Okay. Like I will talk about exclusive current, share current, pass images, and consistent rate. So the block can have multiple status. Okay. So depending on how it is being requested. So we talk about it when we get to global resource directory or global concurrency control when it comes to R.A.C. Okay, so I'll talk about the block status. So definitely it can be an exclusive mode because if, for instance, I'm trying to update a block, okay, and a block contains row, right? So if I'm trying to update anything on a block, there are some locks that will be created on that. So if someone from the other instance is trying to request for the same block, they have to wait, right, till I release the locks. So they still the locking mechanism still work here. Okay, it's still possible for you to lock a session while other people are requesting for the same block. Okay, but now what differs is that we just start talking about block status. Start talking about those 4 types of blocks that I will have to explain later on.
Okay. And I also want to find out if this node X and node Y, they are databases also.
No. A node is a server. Just take server.
Okay, like a server.
They are server, yeah. A node is a server. Node equals server. Node is just a terminology specific to R.A.C, as Ms. Anista said earlier.
So at what point do we see the database? Like, do we create the database?
On DBCA, when you create a database, you specify on which node you want it to run on.
Okay.
Okay, at the creation, you create it. You can decide that you create a database if you run only on one node. You have that option. If the R.A.C environment, right, is installed on 3 nodes, it's not mandatory for you to create a database on those 3 nodes. You can decide that my database I'm creating will run only on 2 of them, or only on 1 of the nodes, or on all the nodes of the R.A.C environment. Does it make sense? So you still have the choice to decide where you want the database to run on. Does it make sense?
Yes.
So yes, you guys will do it when you install the cluster. Part of the configuration, I totally forgot to show it in the morning class. Let me just do it in the evening, and I will make a short video for them so that they can easily see where we can get that video. So you guys have come on. So you guys have a canvas, and on canvas you go to your project, and on project you scroll down. You go to R.A.C. There's a lot of stuff on R.A.C here. Okay. You go to R.A.C installation, the last link. If you guys can see the last one, right? R.A.C installation in bracket you see Bronte. Okay. So you click on it, open in a new window, right? It will open on a new window. Oh, what happened? No longer available? Oh, interesting. Very good. Very, very, it's good I saw that now. Okay. So what happened? Very good, very good, very good. Okay. We are going to see, wow, what happened to this? Next. No. Interesting. Give me 1 second, please. Let me contact these people. All right, so we are going to figure out, okay, but that should be available very, very soon. Otherwise, I will have to, to install it so that you guys can see how it works. Otherwise, that will be the only option, okay? Me installing it, and you guys will just get the recording, and then you can just proceed, right? So, okay. We'll come back to it. I'll have to hear from them and get back to it. Definitely that's where it should be, unless there's a new one coming up. Okay, so all right, so definitely last session, we tried to talk about the R.A.C, what is R.A.C, the difference between single instance and R.A.C. Okay, what new you have, okay? What is new is just, the grid infrastructure that you guys may need to install, okay? You may need to install the grid infrastructure, and the grid infrastructure will come with two main components. What are they? What are those main components of the grid infrastructure?
The clusterware and the ASM.
Okay, good. What are the benefit of each of them? What is the clusterware used for? And what about the ASM?
The clusterware allows the communication between the two instances.
Two servers.
Two
Yeah,
nodes, right?
Instance.
Two nodes. On whatever server is installed, we allow the communication between those servers, those nodes. So whatever is on each node, right, we will be able to communicate because of the clusterware. Okay? The clusterware is not instance specific. So if the clusterware is installed on a node, right, all the instances of that node will be able to communicate with any instance of the other node. If you enable a parameter called, you enable SSH, that is something else. So yeah, just take it at a node level, okay? The clusterware is installed on a node. It's for a node. It's not for an instance. Okay? Otherwise, you may need to install the clusterware multiple times for each instance. If you guys want to take it that way, right? If you say that this clusterware is for this instance, it means that if on a server I have multiple instances, it means I also have to install the clusterware for other instances. I don't know if it makes sense what I just said. Does it make sense?
Yes.
So the clusterware is a server level resource, right? You install the grid infrastructure and you call it a clusterware, and it will be there to manage all the instances running on that particular server or that particular node. So don't take it as an instance specific resource. It's a server level resource. Okay?
Yeah, Mr. Gatton, excuse me, just a little clarification. You said the green infrastructure is the software. That software is coming from the clusterware and the ASM. That's software. Is you go install different node, or you have to install inside the one node for the, maybe if you got two nodes, like two instances.
You guys can see here, right?
Yeah.
The grid infrastructure, you guys see that on each node. Grid infrastructure on the left, grid infrastructure on the right.
Okay.
It means that it should be installed on each node.
Okay. Thank you.
You're welcome. Okay. Before we proceed, can we all turn on our camera, please? Really quick. I know today is Friday, right? So we look tired. I know. Okay. I think there's still some people offline. Okay. Okay. So few people, Sakisa and who? And only Sakisa International. Okay. All right. So today we are going to move a little bit, okay? Before we come back on Monday. So last class, we said that the cluster where we had very critical configuration files, and we talk about the OCR. We said that the OCR is one of the main configuration files of the clusterware, and we said that the OCR stores cluster related resources. Like it will tell you all the IP addresses involved. It will tell you the number of nodes you have. Okay. And it records all the status of the node, everything. So whatever happens on a particular node, the OCR records it. If the node is not available, the OCR knows it. Okay. And you guys can also, more differences can be found somewhere. Okay. You have more other stuff that you can find on the OCR, like the number of listeners, the number of ASM this group. I will talk about what are ASM this group when we get there. The number of services, if you have database services, right? I will talk about it. Okay. Where the backup of the OCR is located, I will talk about it. Okay. And also the number of RAC databases. Okay. So the OCR, is like that control file, right? So it knows where each of these resources are located. Okay. Does it make sense? So definitely that is how it works. Okay. That's what you can find on that OCR. Okay. So today we talk about other files. Okay. Than the OCR. And I said that the OCR is updated by a process, the main process that updates the OCR is the, okay. And the cluster ready service daemon, basically, is one of the key processes of the clusterware. So those processes come with the clusterware, okay? So when you install the clusterware, it comes with some configuration files, and it also comes with some workers. And that is totally normal, right? Because the control file is useless without a process coming and updating it. If there is no checkpoint process that is there to update control file details, which process is going to do that? The control file is just a file. So you need a process that will come and update the file, right? And record. Whenever there is a change, the process will come and update. So that is the same thing with the OCR. Okay, there's a process that should be coming, updating the OCR, whether it is up or down. Okay, whether the node is up or down, or the status, whatever is happening, it's a process that should come and update the OCR. And the main process doing it is the cluster ready service daemon. And that process is among multiple other processes I'll be talking about today. And I'll be talking about 4 of them. Okay. So you have the cluster ready service daemon. We have the cluster synchronization service daemon. We have the Oracle high availability service daemon. And I'll also talk about the event manager. These are the key clusterware, resources or clusterware processes. So these are part of the family called CRS family, okay? Cluster ready services. So these workers are the ones to do the main job to make sure that the clusterware is working properly, okay? And not just the clusterware, but also they also interact sometimes with the ASM, okay? But these are mainly dedicated to the clusterware. So this one is what I said that is mainly linked to the OCR, okay? And last class I said that this process is also the one that will help you to be able to start and stop the clusterware, okay? It's the one that completes the startup of the clusterware. So whenever you want to manage a clusterware resource, start or stop a clusterware, this process will be running in the background. Does it make sense? So 1 second. Okay, Miss Anita, when you are comfortable, you can turn on your camera, okay? I don't want you to feel uncomfortable. So, yes, I don't want people to be distracted, right? So if you feel comfortable, you turn on. If you don't feel comfortable, you can stay like that, okay? It's totally fine, okay? So,
Thank you, Doctor.
okay, you're welcome. So, what I was saying was that, the CRSD, okay, is the main process, to be updating the, the OCR. And whenever, okay, a resource is added to the clusterware or anything wrong, the status of the listener, everything, this process is the one to update the OCR. And again, you guys will learn about a tool called CRSTTL. Okay, so the CRSTTL is one of the tools you guys will have to learn, know how it works. Whenever you call this tool in the background, the process is also called. 1 second, please. Prof is calling me. Maybe.
Mr. Jones.
Gatan, you are muted.
Oh, sorry. Thank you. I did not know. Thank you so much. So what was I talking about? Why muted? So okay, let me go back there then because okay, I was saying that the second process I'll be talking about is the cluster synchronization service daemon. Okay. So this process, is definitely what also helps to ensure the communication between the nodes. Okay. So what do I mean by that? It means that each node will come with this set of processes. Each node. Okay. So for me to say that the cluster where is available is that all these processes should be up and running. All of them. Because each of them have their own role in this stuff. So if the CRSD is up, but the CSSD is down, nothing can happen. Okay. So for me to be able to take advantage of the cluster where all these guys should be up and running. Okay. So whenever you are starting a cluster where using the CRS start CRS, for instance, all right, or if you want to start cluster all, you want to start all of them on both nodes, there are some command on that. But you guys should just know that those two should be up and running in order for me to say that the cluster was, all of them should be up and running in order for me to say that the cluster was running, okay? And in order for the rack environment to function, okay? That communication and all those stuff I'll be talking about, all of this should be up and running. So it means that on node 1, on node X, I will have CRSD, CSSD, or I could have availability service daemon and event manager, right? Same thing over here. Okay, those set of processes will be present on node. If I have 3 nodes, it means they will be present as well on the 3rd node and so on. So the illustration I will do now will be, for, a couple of nodes. And I will say that what I just explained, right? The CSSD I just said, right, will be on each node. So let me take, node 1, node 2, node 3, okay? And on each node, we have CSSD, okay? So it means CSSD here, CSSD here, CSSD here, okay? I'm not talking about other processes, right? Automatically, they are also here, okay? CRSD on each node or other stuff, okay? So what happened is what? What happened is that each node have to validate, to check the availability of the other node every second, okay? So it's like it's a communication. We talk about ping. Each node should ping another node in order to make sure that that node is available, okay? That node is responsive. What do I mean by that? Let me take an example. Let's assume I'm calling anyone on the phone. I call you, right? It's not video. Maybe I cannot see your facial. we'll try to see if we can fix it as soon as possible. So I was saying that on each node we have the cluster synchronization service daemon. Okay, and that process is actually what how to ensure node communication. And I was going for an example, the example of having someone on the phone, right? And I was saying that let's assume I call any of you, okay? Let's assume I call Koji, and I call Koji, he picks up the phone, and I say hi. Okay. Normally, Koji should reply back to me hi, right? In order for me to proceed with the communication, okay? So that is how they check their availability, okay? So it means that the CSSD of node 1 is going to ping the CSSD of node 2, and also is going to ping the CSSD of node 3. Depending on the number of nodes you have, that process has to ping other nodes, right? And vice versa, the CSSD of node 2 has to reply back to the CSSD of node 1, and also has to ping the CSSD of node 3. So each process they have to ping each other in order to validate their availability. So it means the arrow will be like this. I ping you, you reply to me in order for me to know you are alive. I ping you, you reply to me in order for me to know you are alive. I ping you, you reply to me in order for me to know you are alive. That's how it works, okay? So they will ping each other every second. Okay? Every second, they will ping each other to check each other availability. Okay? So, and that is not enough. That is what we call network heartbeat. So they will check their network heartbeat. So they will check whether they are accessible to the network. So you guys should not forget that there is something in between here called the interconnect. Okay? From this architecture, you guys saw this interconnect, right? So they ping through the interconnect. The interconnect is a cable, okay? These are physical cables that are connected between the machine. So this interconnect is actually what will allow the ping to happen. So it means that through the interconnect, node 1 is going to ping node 2 and vice versa and so on. What actually does the ping is the CSSD process, okay? So, and that is not enough. That's not the only thing that happened, right? That's not the only ping that happened. So the ping at the network level, they also ping at the disk level. So at the disk level now, that is why we're talking about the voting.
You're muted.
Going to need the other ones? That's the better question.
Sorry, it was not even him. Someone else, another student. I thought it was the same number. So, that's why I don't like using my phone. So actually, voting files, as I said on 12C, right? We call them voting files. On 11G, you mostly hear voting disk, the same thing. So these voting files are actually those files that record node membership. It means what? The OCR will just tell you how many nodes we have. The OCR will just tell you all the listener, everything, right? But actually, what actually checks the availability of the node, whether the node is up and running, whether the node is responsive, is the voting disk, the voting file, okay? Let's take the voting file. So it's there to check the availability or the health of a node. And how does it check it? Every second as well, the CSSD process of each node also have to go to the voting disk and record their disk heartbeat. So let me just make a quick picture, that's easier. So let's say it's like a table, right? Node 1, node 2, node 3. What I mean is that, nodes, the voting disks, the CSSD of each node also have to, sorry, let me complete this thing. So it's like this. It's like every second, right? So I assume every second, the CSSD of each node also have to go to the voting file and check, yes, I'm available. Okay. The CSSD of this one also has to go to the, the voting file of node 2 and say, yes, I'm available. And same thing for the CSSD of this node, also have to go to node 3, okay, and say, yes, I'm available. Okay. So every second. So it means you go on the voting list, you signal your availability, it's like a check, right? And the check is also very important. So once a node goes to the voting file, it says that, yes, I'm available and I can reach out to other nodes. So you will not just go and check, your own availability, right? You also report on the voting file the availability of other nodes. So it means that node 1, for instance, we go to the voting files and say that I'm available, node 2 is reachable, node 3 is reachable. The CSSD of node 2 will also go to the voting file and say, I'm available, node 1 is reachable, node 3 is reachable. The CSSD of node 3 will also go to the storage and say, yes, I'm available, node 1 is reachable, node 2 is reachable. Okay? So that is how it records its availability and also the availability of other nodes. So if now something happened to any of the nodes, okay, now the process will also report it. So if node 1 is not able to reach out to node 2 or node 3, node 1 will also report it to the voting disk that I'm available, but I cannot reach out, or I could not reach out to node 2 or node 3. Okay, that is what will actually help the voting disks or the voting files to know which node is not responsive and remove that node from the cluster well. Because what is the benefit of R.A.C? R.A.C is that all the nodes should be responsive and talking to each other. So if there's one node that is not communicating with other nodes, it's defeating the purpose of R.A.C. It should be removed from the cluster. Does it make sense? To avoid data corruption. And I think I explained the danger, right? Whenever nodes are working separately. I said that if node 1 is not communicating with node 2, and node 2 is not communicating with node 3, for instance, that means they're working independently, right? In that scenario, you can have block corruption, just based on the example I explained last time. That node 2 we won't be able to, will not know what's happening on node 1, and node 1 will not know what's happening on node 2. So they could be updating the same data and be trying to write the same data to the disk, causing the corruption. I think I explained it last time with the employee salary that you are trying to update twice. Okay, so that scenario whereby nodes are trying to work independently is called split brain. And we don't want it. We don't want it to happen. We don't want a split brain to happen, okay? Because split brain means nodes are trying to work separately, individually, right? They are not communicating with other nodes. They are just running, okay? But they are not talking to other nodes. And in that scenario, we have a split brain, okay? And we don't want this split brain. It can cause block corruption. Does it make sense? So at some point now, whenever they are not able to communicate like that, the voting list is going to determine which node it has to remove from the cluster well in order to avoid the split brain. One has to leave. If we have 2 nodes and both are not communicating, one has to leave. If you have 3 nodes and one node is not communicating with other nodes, it has to be removed. And there's a mechanism used by the voting list in order to remove the wrong node or the node that is, that is not communicating with other nodes. Okay. Okay, so you guys can see that the CSSD and the voting file are mainly the two that will help you to, to check the node availability and also to remove the node that is not responsive. Okay, so we have to know that. So that's how I can relate the CSSD with the voting file. Okay, that's how they are related. But the CSSD is the one to complete the voting file with the node availability or the node membership information. Does it make sense what I just said?
Yes, sir.
Does it make sense?
One question. So if one of the nodes is not working, you said you have to get rid of it. Is there a parameter to configure so that it will be drop automatically?
Automatically, if a node is not responsive, right? First of all, we have some metrics that you will set in order to detect that, right? Before you even stop. Let's assume the node is not responsive, it's not communicating with other nodes. There are some you can set some threshold so that at some point a notification will be sent to you or a warning will be sent to you, okay, that this particular node, okay, has an issue. There are some log files as well. You can check from the log files. And I will talk about one of the log files, bar log messages, in order to check whether a node is not responsive. Okay. So normally the node is removed by the clusterware or by the voting jigs automatically. Okay, it's not something done manually by you. Okay, so because that's something running, right? I will talk about node eviction. How a node is evicted. So if node 2 is not communicating with neither node 1 nor node 3, because we don't want data corruption, at some point, okay, the voting jig will remove that node from the clusterware automatically. Okay, without you having to come and do it manually yourself. And it makes sense. But you, the DBA, you will get notified. You will receive. You can set up some metrics, right? So that whenever there is something going on, something wrong is happening, maybe you are receiving emails or there's a ticket that is coming to you. Okay, but the eviction is done by the voting itself automatically. I don't know if I'm answering your question.
Yes, you did.
Okay, thank you.
So hi, Gaita. Earlier I think you mentioned that the interconnect is like a physical connection. So it's by cable.
Cable, yeah.
So that means all servers have to be in the same room, like same location at all
That
times.
is what I say about R.A.C, right? All of them are in
Okay.
the same room next to each other.
Okay.
Yeah.
So that means you can't have like too many servers at the same time.
Exactly. Whenever you have too many servers, it can also cause, the traffic, because you have multiple tables, right?
Mm-hmm.
Can also cause interconnect issues. That is one of the main performance issues when it comes to R.A.C, the interconnect. So having too many servers, it means we also have multiple cables that have to go across, right? And on 12C and above, we have a fix for that. And I'll talk about flex cluster. Okay, that one definitely helped to resolve that, the cabling issue we had on R.A.C, and it also helped to, ensure high availability of the node. Okay, so you can have multiple, but on 12C onward, flex cluster can definitely help to reduce the overhead. Okay, and the cabling issue we have on R.A.C.
Okay. So a follow-up question. So now that you say that we can't have too many servers at the same time, at Brontech, like how does it work? How do you guys allocate the servers to us?
No. I'm not saying, I never say we cannot have multiple servers at a time. We can have, but the more servers we have, more cabling, right? More connectivity we need between the servers, correct? They work, right? But you may have a lot of performance issues due to, huge number of cables, and also the overhead, more cable will definitely cause, can cause some slownesses when it comes to the communication between the nodes. I'm not talking about cabling issue, but I'm not saying it's not possible. It's very possible. Okay, it's very possible to have multiple servers. Now in Brontech, hey guys, in Brontech, we have physical servers. Okay, and it doesn't mean that, if I have two physical servers in Brontech, it means that one physical server is used for RAC, and the other one is used for one instance, the other one is used for the second instance. No. We have what we call virtualization. Okay, it means that when we buy a server, it comes with a huge amount of memory, huge amount of CPU, a huge amount of disk, okay, of space. Okay, all those one come with a server. Now, because it's a school, right? So what happened is that we install on top of those servers what we call an hypervisor. The hypervisor is there for what? With the hypervisor installed, you are able to virtualize the server. That means what? You are able to split that server into small chunks of servers, smaller servers called virtual machine. So you guys now are assigned each of those virtual machines. So that means student 101 has one of the virtual machine, which is a chunk of, it's just a part of the entire space, right? Student 102 has another virtual machine, and so on. So it means that if I want to configure RAC, I can just take two of the virtual machine and configure RAC with that. I can just take student 101 and student 102 and configure RAC. That is one is virtual. Does it make sense?
Yeah, it makes sense. So like I was just wondering, so as far as maintenance, do you think it's going to cost more for maintenance when you divide the servers like that?
No, it's virtual, right? Definitely, it even helps you to save when it comes to cost. Okay. The maintenance is just the maintenance of, you have to make sure that the hypervisor is okay. That means you need some skills in order to monitor that. Okay. The maintenance is at the level of the physical machine. Okay. So now, another type of fix will be in case there's something wrong with one of the virtual machines. Like sometimes some student server can fail, right? It's because there's something wrong that happened to that server. So other stuff are mostly software related. But when it comes to hardware related, only one machine is involved, because you just took that machine, install an hypervisor, virtualize it, and the virtualization helps you to split that server into multiple virtual machines. You guys don't see a virtual machine, right? It's not the physical stuff, it's virtual, as you guys understand, as you guys can hear me, virtual, right? So it means that they don't have a platform from where they can monitor those virtual machines. The maintenance is the same. Okay, the maintenance, the physical machine maintenance is the same thing. But when it comes to the virtual machine or the hypervisor, that is software maintenance. So you need someone who knows how to work on the hypervisor. The hypervisor is a software, so that means you also have to patch it, you also have to update it, and so on. Okay, so it doesn't have anything to do with the hardware maintenance.
Okay.
Yeah.
Okay. So now when you come to the voting, is it a voting file? So
On
does it
12C they are called voting files. On 11D they are called voting disk.
okay. So does it override like after some times does the information override itself?
Override. Let me think about that one. There's always, like the control file has a certain time, right? At which it is, how do you call it? Those information can be deleted, right? The control file retention. Control file has a retention, right? Let's take an example. Retention for the backup. The retention of the backup in the control file is 7 days. That means the control file will keep the backup information for 7 days. After 7 days, they will be deleted. Okay, so that means there's also a retention at some point in the voting file, so for the cleanup. Okay, that I don't really know, but information are not that overrating. It's not like it stores information. It just there to record the availability, the check, that's it. So it means that the voting file not being available doesn't mean you are losing data. You are not losing any data. But what happened is that the cluster will stop functioning because it's necessary for the voting file to exist, so that, okay, we will know which node is available and which node is not available. Okay, so the content of the voting file is not that important because it's not, those are not the data you need. Okay, those are not the physical data that you need, for the clusterware. You just need to check the availability, the heartbeat. Is this node up and running? Is it available? We check it, that's good. If not, you will remove the node if that node is not available. Okay, so but there's a mechanism to manage it. Okay, because the voting file is at the same location with the OCR. So in case that space is, you just have to monitor, the storage, right, where they are stored, to make sure that there's enough space, on that particular group. Okay, so that they don't, the space is not maxed out. Otherwise, there's nothing else you have to do on the voting file. Okay.
Okay, so information from the voting file is also stored in the OC.
No.
The OCR.
Information the voting file are not. Information regarding voting file are not stored in the OCR. They are stored on a different file called the Greek plug and play profile. Okay, on a different file. The OCR doesn't need to store the voting file details. The Greek plug and play profile, we have the voting file details. Okay.
Okay.
Different
okay,
file.
Thank you.
Okay. Question?
I wanted to ask a question, but you said the voting file does not store any data. So because I was like asking if they keep logs.
No, they don't keep blocks. They don't keep blocks. Okay.
Okay.
The data are stored on the storage, right? We split. I will talk about it when it gets to ASM. Okay. The storage now is organized as a form of group. Okay. So that means what?
Okay.
We have a disk group. A disk group is a group of disks. That means what? We have a group of disks for data, a group of disks for backups, and a group of disks for OCR and voting files only. So they have their own storage, they have their own disk. Okay, so they are just there as a repository. The data itself and the blocks are stored on a different group. Okay, this group. So we'll get there and I will talk about it.
Okay.
Okay, good.
All right.
Another question? Okay, so just talk about how they communicate, okay, and how important the CSSD is, and also it is also done every second, okay. The heartbeat is also done every second, okay. Okay, so this is the CSSD. The other process, is the Oracle High Availability Service daemon. This process is the first process to come up when you are starting your clusterware. The first process to start when you are starting your clusterware. So if you are saying that the clusterware is starting, the Oracle High Availability Service daemon is the first process to start. Is this process who will be starting other processes. So this Oracle High Availability Service daemon is the one that will start the CSSD and the CRSD. So the first process to come up when the clusterware starts. Okay, so when you get to the practicals, as soon as you do CRSD start, this guy come out first, and there's a mechanism behind that will allow this process to start other processes. So, and there's a file, there are some files involved, multiple files involved that this process may need to read in order to trigger, the startup of other processes. So one of the files, I said that this one is mostly for the voting disk. One of the main files we talk about, that is the Oracle high availability.
I think you are muted.
If you guys are saying the same thing I'm saying, honestly. Right?
OG, mute yourself.
Hey, what's up?
Okay.
Mute yourself, man.
So I was discussing with, the engineer in charge. So there's something wrong with the third party start meeting. It's another company. So they have to, the next 2 hours, he will give me an update of what's going on. So I was talking about the Oracle High Availability Service daemon. And I was saying that, this process is the first process to start when you're trying to start the clusterware, the first to come up. And this process is the one responsible to start other processes. It means that if this process cannot start, other processes will never start. Okay? So, and this process reads a file called Oracle Local Registry. Okay? The Oracle Local Registry, right, is similar to the OCR, but it is local to each node. Remember, on this architecture, the OCR is on a shared storage. Whenever you see a file on a shared storage, it means that it is shared by node, right? That means node 1 and node 2 are using the same OCR. But the OLR is local. That means the OLR of node 1 will be on node 1, and the OLR of node Y on node 2 will be on node 2. So, and the OLR is the local registry. That means that is where each node stores its local details. This is a small table I created long time back between the difference between OCR and OLR. This is an interview question, okay? So when you get there in the interview, you guys will be seeing some copies of my OneNote all over the places. But there's some criteria you guys need in order for me to be giving you the latest one. So I was saying that, the OLR, we also contain some local details about the server. If you guys pay attention, you see that this one, the OLR can actually stores node name. The OCR doesn't store the node name. It just tells you how many nodes we have. The OLR itself will tell you exactly the name of that node or the name of the server. So it means student 100, we give you the name, right? Student whatever, you give the name. The OCR will not give you the name of the node. Also, the information, the version of the node any local version, the local host version. That means what is the version of the operating system? Okay, we can give you those details. The clusterware configuration detail. Whenever the clusterware is configured, some details has to be stored somewhere, right? So the OLR will also keep those details. The grid plug and play details, information regarding the grid plug and play, and the grid plug and play itself, is what actually helps us to it keeps network related details. We mean that on a grid plug and play, we can identify the network details like the listeners, IP addresses, and so on. And the home, the Oracle home of the clusterware, okay, the grid home. So when you are installing the grid infrastructure, right, the home of the grid will be identified here. And also the information about, you know, the OCR backup, okay? So because the OCR, because it also have to be available, its backup is also taken frequently, okay? So its backup, the backup of the OCR are stored on a local node. What do I mean by that? It means that the OCR which is on the shared storage, automatically Oracle will be backing up this OCR every 4 hours, and the backup of the OCR will be stored on one of the nodes. Okay, and from that node you have the daily backup of the OCR, the hourly, that means the backup of every 4 hours, the backup of the day, the backup of the week, and the backup of the month. Okay, so you have about 4 copies over there. So for the day you have 3 backups. That means every 4 hours, right, 1 backup is taken. So you have 3 copies of 4 hours. Okay, now you should have 5 in total. So you have 2 copies of 4 hours. That means after 4 hours, the first copy, the first backup, right, is taken. After the other next 4 hours, another copy is also backed up and stored there. For the entire day, there will be 1 copy for the entire day. For the entire week, there will be 1 copy. Okay, and I think for the entire month as well. I think it stopped the week or the month. You have to verify that. So the OLR will be keeping this information, okay? This local information. So when the Oracle High Availability Service daemon comes up, it needs to read the OLR in order to start other processes. You need to read those details, identify the node name, identify, you know, all the clusterware configuration, all the processes involved before it can start other processes. Okay, so that's something that happened in the background. Okay, so just wanted you guys to know what the Oracle High Availability Service daemon is used for. And the last process we talk about is just the event manager. The event manager, as you guys can hear the name, event. That means whatever is happening, the event manager will record those events and is going to store those events on this log file. So it means that there's a log file for the event manager. So you want to know what's happening, you can just go to the log file of the event manager and you'll be able to see all the events. Also, each of the processes here also have a log file, okay? So this one also have a log file. That means if this one doesn't come up, you can check this log file to figure out why. The CSSD also have a log file. If there's something wrong, it can also tell you. The CRSD also have a log file. If there's something wrong, it will also tell you. Okay? So each process has a log file. So to troubleshoot the process, you can go through its log file. Sometimes it's helpful. I will talk about other log file involved in the R.A.C environment. Okay? So those are the 4 key processes that should be up and running for you to be able to take advantage of the clusterware. Okay? So, and you guys should be checking the status of this whenever there is something wrong with the clusterware. Make sure that they are running. Okay? Any questions? Moving to something else.
Gada, you say the backup for OCR is go store to the one node.
Yeah.
If that node is gone down, that's mean you got a problem to OCR. That's mean like the rack go down too.
Now you have if the node is the node fails, we have
Yes.
dynamic configuration. So all those resources will be moved to the other node.
Okay.
Yeah.
Thank you.
Okay, dynamically.
Dynamic. Okay.
Any question? Okay. So we talk about, now what can cause the node eviction. And I will start explaining, I start with where we stopped before I come with other reasons. This is where we stopped, right? We said that the CSSD on each node has to check whether the other CSSD is responsive. It also has to check whether, it also has to update the voting file, right? And tell and mention its availability to the vote in the voting file. Okay. So this is also done every second. But what if CSSD of node 1 is trying to contact CSSD on node 2 but it's not responsive? Okay. You will keep on trying. You won't give up. But you will not try forever. You will not try forever, right? There's a threshold. By default, the threshold, we call the parameter that define the threshold CSS miscount, which is equal to 30 seconds. What does it mean by that? It means that the CSSD of each node will keep on trying for 30 seconds. After 30 seconds, it will stop trying to reach out to the other node. Does it make sense what I just said?
Yeah, so to me, it sounds like it only tries once.
No. It tries multiple times.
Within the 30 seconds.
So multiple times within 30, okay.
It tries, that means it tries 30 times because it tries every second. That means 30 seconds is the threshold.
Okay.
You stop trying at 30 seconds. But before that, you will get notified if you set up some metrics or some jobs to monitor that. You don't have to wait till the 30 seconds, right? But in the environment, we increase those parameters because 30 seconds is very small for you to come and act on it, right? In 30 seconds, you cannot fix an issue. Does it make sense, what I just said? If for instance, right, it's at the level of 20 seconds, that means the first alert you receive is after 20 seconds. That means you have 10 more seconds to act on it, right? Before that node will stop communicating with the other one. You have just 10 seconds. Do you think you can log into a server for 10 seconds and fix the issue before it happens? You cannot, right? So that's why even for the configuration, you guys will increase this parameter. As somewhere in the, in the configuration, you guys will increase the CSS miscount, and I will talk about the big timeout. You guys will increase it because it's very small. But you guys should know that it's not supported, okay, by Oracle. Whenever you increase it, there's something wrong, Oracle will not help you. Oracle recommends you to keep what they provided. So 30 seconds is the threshold, but if you keep on trying, it's like the same thing, right? If I'm on the phone with you, I will say hello. If you don't say hello, I will not hang up right away, especially if I know you. I will say hello the second time. Till I notice that you are still not responsive, and I will hang up. That's the same thing. It's not trying only once, it's trying multiple times. Okay?
Mr. Gada.
Yes.
If one of the nodes is not responding, is eviction the only option?
Eviction, definitely, because if that node is not responsive, it can cause corruption, right? Because how will I know which block is stored on you on your instance? How will I know? It's like a split brain. That means that node will be working independently. So in order to avoid block corruption, that node has to be evicted. Okay, it has to be evicted. The node eviction doesn't mean that it crashed. Okay, what happened is that the eviction means that Oracle will try to reboot that node for you, because sometimes by just rebooting a server, the issue can be fixed. Okay, so eviction means what? Eviction means node reboot. So the node will try to reboot. Maybe by rebooting, if after the reboot, it can fix itself. After the reboot, maybe it will be able to communicate with other nodes. But if after the reboot, it doesn't communicate with other ones, it will stay at the down stage. So you, the DBA, will come and fix it. Or otherwise, it will be removed from the clusterware. It means the clusterware will stop considering that node. Okay, other node will be considered. That's what will happen. Does it make sense or not?
Yes, it does. Thank you.
All right, welcome. Okay, so I will take a scenario to explain what we call eviction due to missing network habit. Okay, missing network communication. My scenario is what? I assume that I have an issue with node 2. I assume, right, that node 2, there's something wrong with node 2. And because of that, node 2 is unable to communicate with node 1 and node 3. But node 1 can communicate with node 3. Okay? So that means, let me assume that this thing is not working. This link, right, is not working. But the other link is working. What will happen at the voting disk level? Node 1 will go to the voting disk and say, I'm available. Node 2 is not available, or node 2 is not reachable, and node 3 is reachable. Node 2 itself will also go to the disk, voting disk, right, and say, I am available, but node 1 is not reachable, node 3 also is not reachable. Node 3 also will go to the voting disk and do the same. I am available, node 1 is reachable, but node 2 is not reachable. You guys can see that all of them are complaining, right? All of them are complaining. All of them are signaling their availability, but they are complaining about others. Which one is, we will consider the bad node? The node 2 will be considered the bad one, because the number of people that are complaining, okay, are more than, okay, we have more people complaining about its unavailability. The majority here, right, is complaining about node 2. I don't know if it makes sense. So node 1 is complaining about node 2, node 3 is complaining about node 2. So it means node 2 is a bit problematic in this scenario. So, and in order to avoid a split brain scenario, in order to have, to prevent node 2 from working by itself, node 1 and node 3 are going to write, to request the voting disk to remove node 2 from the cluster. Okay? They will request, that will be the request, because they try, right? After 30 seconds, of course, they will request node 2 to be evicted. And the voting disk now will make sure that it writes a poison for node 2. So the next time node 2 will come to the voting disk, node 2 will drink that poison and die and evict itself. So you guys will see online, they will talk about poison pill. So the poison pill has been created because node 1 and node 3 were the one to request node 2 to be removed. Okay? And because of that, they drop a poison. Poison pill is like, okay, they drop a poison, and the poison Node 2 drank the poison and died. Okay, so that is basically what will happen at the voting list level. After node 2 drinks this poison, we evict itself, we reboot itself.
You're muted.
It'll be some bad class. Remember.
What did you say, Vali?
Oh, Mr. Patrick,
Yeah,
I
Vali.
told myself I'm not meeting because I'm feeling sleep again. Long day today. I was feeling sleep.
Okay, so now the recording is available, okay, on Canvas. So you could just follow the same path I show you, okay? You just go to rack, go all the way down. Just get this one, okay? The latest link, you click on it. You open a page like this, you click on it, and you open a video for you, okay? It's a 4-hour video. It is lab created by Ron, 3 hours 50 minutes. He's the first teacher who was teaching project in Brontech, okay? So he's still there, sysadmin. He's using two servers. He will show you how to configure everything, okay? So please, I will put this one on the chat, post it on the merge group, okay? I mentioned there that that is the, that is the recording for the rack installation, so that even people do one in the morning class will take advantage of that, okay? One of you, let me post it on the chat, so that one of you can just, forward it to your classmates. Why am I unable to? I'm not seeing that chat.
Mr. Gata, is it 11G or 12C? This configuration.
Okay, this one is 11 GB. I will show you guys the difference with the 12C. Okay, there's nothing different. I'll show you the small difference.
No problem.
Watch this video in order to get the steps. I will tell you where they differ.
Sir, so our servers already have they been prepared for rack?
They are still in under preparation. Just run this one. I think normally I told folk that they were supposed to be ready by Wednesday, by Monday. I will check with him again if they are already. But he's supposed to send me all the servers. Okay, so I will check. I will validate that.
Okay, so we shouldn't do anything for now, right?
No. I want you guys to understand the concept.
Okay.
Instead of trying to configure now, because the configuration, after you watch the video, you have the steps to configure. Instead of doing it now, read read more on RAC, right?
Right.
Resources, yeah. That's my recommendation. Where is it? I'm trying to open the chat. Okay, I saw it now. It was hidden somewhere. Please post it and say, RAC, video, something like that, video to configure RAC provided by Gaitan on the merge group, so that they know that they have to click on it and follow it in order to be able to to configure RAC. You guys can also check if you guys can read that. It's on the chat already, so just click on it.
Yeah, it's working.
Okay, good. So just share it to your classmates on the merge group, especially, so that they can get it as well. I did not talk about it in the morning. Otherwise, I could have detected the issue earlier. But it's fine. Okay. So I just explained, no detection due to missing network heartbeat, okay? And also we have no detection due to missing disk heartbeat, okay? Because each node also has to go to the voting disk in order to signal its availability, as I said, right? But the voting list will be patient enough for 300 seconds. No, 200 seconds. Sorry, it's not 300. Let me roll that. For 200 seconds, this one is the parameter is called disk timeout. This timeout, right? The disk timeout is equal to 200 seconds. It means that this is the threshold at which, the threshold, the voting disk, at this threshold, right, the voting evict the node. Now, what can cause the voting disk to evict the node? By default, we have 3 voting files, 3 copies of the voting files. By default, 3 copies. That means voting file 1, voting file 2, voting file 3. You can have 1, you can have, okay, any type of number you want. What are those 3 files? Just for fault tolerance. In case one is corrupted, something is wrong with one, we have multiple copies, okay? Just, just to avoid single point of failure. Now, but for a node to survive, the node has to be able to reach out to at least half of the voting disk. To half, not at least half of the voting disk, yes, okay? So it means that if I have 3 voting disks, for a node to survive, it should be able to reach out to 2 of them. If I have 5, it should be able to reach out to 3 of them at least, and so on. Okay, so it means that if there is a node that is unable to reach out to at least half of the voting file, the voting disk is going to evict that node on the cluster. Okay, so it means that for you to survive, the voting disk will be patient enough for 200 seconds before you are evicted, if you cannot reach out to at least half of the voting disk. If you can reach out to half or more, that's fine. But the minimum is the half. Otherwise, you have to be evicted. So this is the second cause of node eviction. Node eviction due to missing disk heartbeat. The first one I said was network heartbeat, network communication through the interconnect. Now you have node eviction due to missing disk heartbeat. That means there's a missing communication between the node and the voting disk. And the threshold in this one is different, is 200 seconds, more than the other one. So it means after 200 seconds, if the node is unable to reach out to at least half of the voting disk, you'll be evicted from the cluster. Okay. There are multiple other causes that can cause a node to be evicted. If the CSSD goes down on one node, the node also goes down. The CRSD goes down, the node also goes down. You see that that the node will not go down, sorry, the node will be evicted. Let's not take node go down, please. The node will be evicted. That means the node will no longer be part of the cluster well. Let's not take node down. Okay, the node is upper, the node is available, but it won't be part of the cluster well anymore. Okay, so also if the amount of resources on a particular node is rich, that node will also be evicted. What do I mean by rich? Each node or each server has a certain amount of resources, right? See, the RAM is 100% used, the CPU 100%, or the swap space 100%. Okay, that node will also get evicted from the cluster. Okay, so you have to make sure that the number of resources is also not rich. Okay, 100% rich, and all the environment should be that proactive. All the environment should be that proactive. So in an environment, normally there should be some job to check the health for the system. not like you guys are having some issues now. Some people have their user one or data 100% used. But in real environment, you almost never happen without you being notified before. It means that they are going to set up some metrics or or create some share script, some jobs that will be checking your system maybe every 10 seconds or every 5 seconds, depending on how long they want it to be, right? So why are those jobs running? Those jobs are there to check the amount of memory, right? Let's assume that when you are creating the job, you say that if there's any mount point that is 98% used, create a ticket for the DBA, or 90% used, create a ticket for the DBA. So we don't have to wait till the issue actually happens, right? Till the memory is maxed out. Before that, we can create some jobs that will monitor the memory. So when it gets to a certain percentage, someone will get notified and we have enough time to go and fix the issue. Okay? That's how it should happen in an environment. Unless it's a new company, right? But it's being proactive when we do that. Okay? We set up some metrics, we set up some alerts. Like the database you guys set up on DB1. You guys set some warning, some critical level, right? When the database was 70% or 75%, you have an alert. When it gets to 90%, you have a critical alert. The same thing you guys can do as well for any other metric in the database or the server. We can create some jobs that will monitor the health of the system, and it will let you notify when the threshold is reached. Okay. So, but when the threshold is reached, if you take too much time, too long to act on the issue, the node will be evicted if this threshold is reached. Okay. So that means several resources being maxed, okay, being reached can also, or several resources being exhausted can also cause, okay, node eviction. Okay. So I think any other question? Any question for me?
Gaetan, please, if you can go to the previous diagram that you had before. Yeah, that one. Okay, so I think you said that so all of these they work like with individual nodes, right? Or is there one that only works with one with the database?
No, individual nodes.
Oh, they work individually.
These are cluster web resources. They work at the node level. So they service all instances running on that node.
Okay. And I think you said that they all have to work, like maybe if the OHASD, it detects if all of them work, and if it doesn't, then the clusterware will not come up.
Yes, I said that in order for others to start, the Oracle High Availability Service daemon should start first, because this is the one that will trigger the startup of other processes. And the startup will be completed when the CRSD will up. Okay. So the final startup is when all of them are up. The final one, the last one to be startup, is the CRSD. But the process that is initiating the startup is the Oracle High Availability Service daemon. This is like a master process. These are like sub processes for this master process. So without the Oracle High Availability Service daemon, other processes will never start.
Okay.
Yeah.
Okay. Okay, I think you probably already mentioned this, but if one, if these processes don't work on one node, the cluster where it was still gonna operate, right? It's still gonna come up and operate properly.
On the other node, yes. If you have two nodes and these processes are not starting on node 1, but they are working on node 2, the cluster will be running on node 2, okay? So everything will be fine on one node only, okay? But the communication between the nodes will no longer happen.
Oh, okay. Okay.
Yeah.
Got it.
Another question for me, guys? Okay. What did we learn for today, class? All right, I need some quick feedback from you guys before we leave. What did we learn today? What anyone can tell me what he or she learned, okay?
I learned that the OCR have 4 processes that should be run in order for the clusterware to operate. And those processes are CRSD, CSSD, OHASD, and EMVD.
Okay, these are the clusterware main background processes. We have other processes, okay, but these are the main ones. Yeah.
Mr.
Oh,
Gata,
yes, Mr. Koji.
I'm sorry to interrupt. I don't know. Maybe I'm confusing. You said it exists at the cluster level or at the node level.
These are clusterware resources, right?
Yes.
And they are running on a node, right?
So all of them basically are also running on the node and are running on the cluster.
What do you mean by the cluster? The clusterware is installed on each node.
So
See,
could you take
when I'm telling you guys that I'm installing the grid infrastructure on this node, after I install the grid infrastructure on this node, it will come with all those stuff I'm talking about. So when I'm installing this grid infrastructure on this node, right, it is coming with a clusterware and the ASM on this node. Okay. And those processes are clusterware resources. So that means those processes will be running on this node as well. I don't know, is it that confusing or what?
No, basically, I didn't get the architecture explanation really well because I'm still getting used to it. I'm seeing like the OCR, right? Mm-hmm. So I'm thinking probably it's a server on its own that manages the node Y and the node X.
The OCR is not a server, it's a file. But the control file is a file, it's a registry.
Okay, it's a file.
Yeah.
So where does it exist?
Store somewhere.
So where does this? Which server does it? Is it
on the storage? Wherever you have wherever you store your files, right? That's where the OCR is. That's why you see it here on the storage. Okay. But when we get to the storage, I will tell you guys that the OCR is stored on its own disk, different from the disk where you store your data and where you store your backups. It's on a different disk. But all of them are in the shared storage, not at the server level or the node level. Whatever you find on the node is just the backup of that OCR. Okay. So the backup of the OCR itself is not stored on the disk. It is stored in one of the nodes. And that the node where it is stored is called the master node. The main, okay, the main node, because between the node, there's always one node that is above the other one, the master. So that is where the backup of the OCR are stored. So the OCR itself is a file. The report is a registry. Okay.
Okay, it's a repository that is stored somewhere.
Repository.
That is stored somewhere.
That's stored on the storage, shared storage.
So do we have access to it?
Huh?
Do we have access?
Yes, you can CD. You can get to the storage. There's a way to get to storage now in R.A.C. You will no longer just CD to Oradata FRA. You will see the Oradata. You just see the data file like you guys used to see before. Mm-hmm. System 01. No. Now, for you to be able to see that, you have to connect to the ASM command line. You can just CD all the way till you see that. You can see the location. You can actually see the file itself. Okay? But you have to be connected to the ASM command line. You cannot see that at the OS level. You cannot just connect to the, like your operating system, as you guys see, and just CD, you get out to it. Simply because the backup, the storage is no longer part of your server.
Yes.
It's stored on a different server, right? So you can just CD all the way till, okay? You can just see it, but you cannot do anything to it. Does it make sense?
Okay, sir. I'm getting a bit by bit.
Okay.
Mr. Gata.
Yes.
Mr. Gata, you said the OCR it look like the control file for customer.
Yes, it's just the easiest way I can identify the OCR for you guys. Just take it like that, like the main file for the clusterware. Yeah.
Yeah, it's the main file for the customer.
Yes.
But the customer is coming when we install the software, the grid infrastructure.
Yes, but all of them come when you install the grid infrastructure. All of them, they come with the grid infrastructure.
The OCR too?
Yes, all of them. Without the grid infrastructure, we don't have all those guys I'm talking about.
Yeah. Because I am just a little bit confused because you say the OCR is stored to the server who contain the database, like the file.
No, the backup of the OCR is what are stored on that server, not the OCR itself.
But where the OCR is stored?
On the storage, the shared storage.
The shared storage.
Yeah. That means it is accessible by all the nodes.
All the nodes.
But the backup of that OCR
yes,
are stored on one of those nodes.
Okay. I want to understand one thing. Because the green one, you go install this one, and the two nodes, like one where install the instance. But I don't understand if you install the green one, the green infrastructure for the two server, they store the instance. Why can the OCS go coming to the node who store the file? Who, I don't know. That's why I make it just a little confused. If you can.
No. When you guys are installing the grid infrastructure,
yes,
there's a procedure you guys will be using to install the grid infrastructure. When
yes,
you guys install the grid infrastructure, in order for you to complete the installation of the grid infrastructure,
yes,
you have to make sure that the OCR is available. Okay, there are some steps you have to create. The disk group. I did not want to get to the configuration level, but
okay.
you have the OCR will be part of the grid infrastructure configuration. Okay, it will be part of the grid infrastructure. So that means it's part of it. So you cannot configure the grid infrastructure without configuring the OCR. It's one of the steps. So while you are configuring the grid infrastructure, when you are launching the HON installer, following the steps, at some point you have to configure the OCR. Create the OCR, specify the disk, choose the disk group before you proceed. So we want it to be on a shared storage so that it's accessible by all of them. If the OCR is local to one of the nodes, how will the other node, read from it? We don't want the other node to be reading files here because we don't store files on servers. We store files on another source server, different from the database servers. So these files should be, all the file on the storage, right? Should
yes,
be reachable by all the nodes. That's what we call the shared storage.
Yes, sir. Thank you.
Okay. You're welcome.
Please,
Anything
Gaita.
else?
Yes, please. So about the voting days, I'm a little confused. So Oracle recommends 3 copies, right?
By default, we have 3. You can have more you want to. By default, you have 3.
Okay,
Depending on the environment, you can have more if you want to.
And do they work like redo logs, as in like, if one is full, it moves to the next one and then to the next one,
Those are
or
redundant copy. So it's not like we did lock like one is overwritten before you move to the next. No. Whatever you find on voting this one is the same thing you find on two, on the same thing on three. They are
okay.
just duplicate copies, right? Multiple copies of the same thing. So they have the same data.
Okay, so there's something here on your PowerPoint. It says a node will be evicted or removed from the cluster if it cannot access the minimum required number of voting disks.
Yes,
So by voting disks, so that means the checks have to be done on each disk at the same time.
correct.
Okay, so and if let's say server 1 does not check disk 1 and 2, then it's gonna be voted out, evicted.
Correct. If you have three voting disks, right, and you cannot vote on 1 and 2, it means you are able to vote only on the third voting disk, right? You should get evicted because you have to ping at least half for the voting disk for you to survive.
Okay.
And it makes sense.
Yeah, it makes sense. But because from your explanation, what you were talking about, each individual servers. Like if one does not listen to the other one, then they are going to vote that one out.
That's what I talk about two scenarios. The first scenario was if they are not able to communicate through the network, and that's where I concluded with the poison pill. And the second scenario was if they are not able to communicate with the disk. Those were two different scenarios. So you can have eviction.
Yeah.
You can have eviction due to missing network heartbeat, and you can have eviction due to missing this heartbeat.
Okay, I got it now.
Another question?
So, sir, what about the Oracle home? Where do we keep the Oracle? Where is it being stored?
Each Oracle home at the server level. You can see here, database home. It's local. Oracle home is local, but you can have a shared Oracle home. If you want to, you can also keep the Oracle home on the shared storage. Like that's what you see here, DB home, but not recommended. And it's not recommended because when you are trying to do some type of patching, it can affect the patching. For instance, when you have a DB home here on the shared storage, you cannot do a type of patching we call rolling patching. And I don't want to get there yet. Okay, so the recommended location for the DB home is at the server level. So each server should have its own DB home. If I'm installing Oracle software, I should install it on node 1 and node 2, and so on.
Okay.
Question? Okay. So thank you guys for your attendance. Please watch the video, okay? Digest it on the weekend. And I will check with Prof, how far we are with your servers. And anytime by the end of next week, I will encourage you to start configuring the end of next week. Now, please, I want you guys to focus a lot on the configuration, on the concept, understand it, ask me a question if there's any doubt, and I will help clarify. And always, right, I will be giving you answers based on your questions. So if you don't ask me questions, there are some stuff I may not go into. So it's your curiosity that will help me that will allow me to explain you more. So if you are quiet, there are some concepts I will never get into. That's why I'm encouraging you guys to be reading whatever you want. My PowerPoint, you have Canvas with a lot of documentation, a lot of documents, Google, whatever you want, right? Read, educate yourself, right? And come and ask questions. If I know, I will throw more light. If I don't know, I will also Google myself, or I will also try it. I will postpone it, right, for the next session in order for me to figure out what it means. So please ask questions, ask questions, ask questions. Okay,
Please,
guys.
I have a question.
Yes.
Yes. I'm sorry. Last time, I think you talked about the local listeners, right? You said there was also like a global listener, but I wanted to know, like, in the local listeners in each node, what kind of information is there going to be in there? Is there going to be information just related to that specific node, or is there also going to be um, information about the other nodes?
No. So, okay, maybe I used the wrong word the last time. I wanted to talk about great listener. It's a great listener. Let's not remove the global listener, okay? Great listener. What do I mean by great? It means that the listener is no longer running on Oracle Home. It's running on the grid infrastructure home now, okay? And that is where, and that the listener is still local, but it will be easier for you to know whether a listener is running on a particular node, okay? Because if someone wants to connect to a R.A.C database now, they should they should connect through the grid listener. The detail on the listener are still the same, okay? The difference is that it's now running at the grid infrastructure level. It's no longer running at the Oracle home level. So that means what? You guys should no longer go to the Oracle home /network/admin. Instead, you guys have to go to grid home /network/admin in order for you to identify the listener.ora and okay and see how it looks like. The TNS name.ora is still running on the database home. So the TNS is for databases, right? TNS. So TNS, that's what runs on the data is found on the database home. The listener name.ora is found on the grid home. And each node will have its own listener.ora. Okay? But what happens is that the listener now is at the grid level, grid infrastructure level, which is a lot it is above the Oracle home. Okay, it is step above the Oracle home, but the Oracle home is below the grid home. If the grid infrastructure or the cluster goes down, it will affect the database as well. So that's why I said the listener is at the global or the grid level. Okay, it's no longer at the Oracle home level. Okay, does it make sense or not? So the listener, right? The listener is local. We have a local listener. We have two types of listener. I'll talk about the other one next time. We have two types of listener: local listener and remote listener. The local listener, each node has its own local listener. So you can stop one local listener, or if you want to, you can stop all the listener using one command. All the local listener using one command. So there's a tool I'll be talking about called SRVCTL that can help you to stop all the listener running on all the nodes because all of them are at the grid level. But I can still stop a listener running on a particular node if I'm doing a maintenance. I can just stop that listener, perform a maintenance, and start it back up. So it's possible as well. Okay. So I will talk about the remote listener the next session because for someone to be able to access the local listener, you have to go through the remote listener for you to get access to the local listener. That's part of the connectivity part of R.A.C.
Okay.
Makes sense or
So
not?
yeah,
Right.
it's clear. Why was it not mentioned on this diagram?
Which diagram? Yeah.
Yeah.
No, because there's a diagram for that, and the diagram is this one I'll be talking about. I will be explaining how connections are routed. We have local listeners on each node, and we talk about the scan listeners in the future.
There are
This is
more
when I'll be talking
listeners.
about. This is when I'll be talking about how connections are routed to the node. When
So
the
you
users,
have
yes.
So you have the local listener, you have the scan listener, and
Yeah.
you have the remote listener.
No, the scan listener is what I call remote listener. I do not want to call it scan listener now. Okay, it's what you call
Okay.
remote listener.
Okay.
Okay, the name of this is also called remote listener. I talk about it when I will try to explain scan. And before I get to scan, there are other things I have to explain before I get to scan. Okay. So the
Okay.
listener is local, H node, but it's run on the grid infrastructure home. It's no longer run on Oracle home.
Okay. All right. Got it. Thank you.
All right, no problem. Another question for me, guys? Okay, so have a great weekend, okay? And let's meet on Monday to proceed with this topic, okay? So enjoy your weekend. Bye-bye.
Bye.